Welcome back, Math 10. Today we're going to learn how to use trig to help us solve problems. So let's start off with the first question here. It says Carmen is a surveyor who is using a transit to determine the height of a tree. The transit is placed 52 meters from the tree. And the angle of elevation from the transit to the tree is 12 degrees. Okay? So now it wants us to find what is the height of the tree given that the transit is 1.8 meters from the ground. Alright? Well, I look at this here. I know this angle's 12. I want to find my height over here. And I know this is 52. So I know my adjacent, and I want to find my opposite, which is my height. So I'm going to use tan. Because TOA, SOHCAHTOA, TOA, I'm using tan. So tan of 12 degrees is equal to my height of the tree divided by 52. Okay, and that's in meters. So I just go 52 tan 12 is equal to my height. This ends up giving me, let's punch that into my calculator. First, once again, remember, make sure your mode is in degrees. So I'm going to type that in, 52, and I have tan 12 will give me 11.05. meters. But now, that just tells me my height from here to here. We still have this section here, which is 1.8 meters. So I must add 1.8 meters to get the total height of the tree, which will end up giving me a total of 12.85 meters, and it wants it to the nearest 10, so that is 12.9 meters is the height of my tree. Now B says, determine the angle the base of the transit makes with the top of the tree. So I want to go from here all the way to the top, and we want to find this angle. Well, I still know this is 52. And from before, we found the total height of the tree is 12.9. Okay? So I look at this here. We know my adjacent and my opposite. So we're going to stick with tan. So let's take a look here. I'm going to have tan x is equal to my opposite, which is my height of the tree, 12.9, divided by my adjacent, which is 52. All right? Continue this here. I want to rearrange this, so I'm going to have angle x is going to be equal to, or my elevation from the base is going to be equal to the inverse of tan. I have 12.9 divided by 52. Okay, so now let's plug that into my calculator. So I'm going to have second tan, right? And I'm going to go 12.9 divided by 52. And I end up getting a total of 14 degrees, because it wants the nearest degree, which equals 14 degrees. So this angle here is 14 degrees, which makes sense. It should be slightly bigger than that one, okay? Because we increased my y, or in this case, my opposite. So let's take a look now at example number 2. So here we have a circle, which has two tangent lines to it, okay? The radius of the circle is 20 millimeters. All right? And they're tangent to POQ. Okay? To angle POQ's tangent. Now this angle right here, it says, is 50 degrees. And now we want to find out what is OC. So this line right here. Okay? Now, if you remember, way back in grade 9, a tangent is always 90 degrees or perpendicular to the radius. Okay, so the radius at the point tangency is always going to be 90 degrees. Now this here is going to divide this angle in half, so this is really only 25 degrees from there to there. And I know this is 20. We want to find angle OC, which is my hypotenuse. Now from angle 25, I know my opposite, which is 20 millimeters. So we know the opposite, and we want to find the hypotenuse. We're going to use sine. So in SOHCAHTOA, we're using sine. Okay? So let's take a look at this. I'm going to have sine 25 is equal to my opposite, which is 20 millimeters, all over my hypotenuse, which is side OC. Okay? Now we want to rearrange this. So I want to switch these two. So I want to get OC is equal to 20 millimeters divided by sine 25. So let's plug that into my calculator. So I'm going to go 20 divided by sine 25. And that's going to end up giving me 47.3, and it wants to the nearest degree, so 47, or to the nearest millimeter, so it's going to be 47 millimeters is this length there. Okay? All right. Next question here. In the diagram, the man on the ground is standing 12 feet from the wall. So this man here is 12 feet from the wall. Okay? So from here to here is 12. The angle of elevation from his eyes to the level of his wife is 62 degrees. So remember, angle of elevation is from this horizontal. It's going to be 62 degrees to his eyes. All right? Now, the man's eye level is 6 feet above the ground. So from here to here is going to be 6 feet. Okay? And the woman's eye level, this is not to scale, pretend the roof goes all the way up like that, is 5.2 feet from the roof. So we know from here to her eye level is 5.2 to the top. She's just a little bit below. Now, we want to know what is the height of the building to the nearest foot. Okay. So first, let's figure out how far it is from the man's eyes to her eyes. We want to find out this here. We want to call this x, and this is going to be the opposite of 62 degrees. Okay, and we know the adjacent is 12. So once again, adjacent opposite, we're going to be using tan. So I know tan 62 is equal to my opposite, which is x, all over 12. All right? I continue this. I'm going to get 12 tan 62 is equal to x. So let's punch that into my calculator. All right, here we go. We're going to go 12 tan, and then we have 62. Enter. I end up getting 22.6 feet, because it wants to the nearest 10. So 22.6 feet. Now, 22.6 feet is from here to here is 22.6, right? But now I know from here to here is 5.2. We also know from here to the bottom is 6 feet. Notice my drawing is not to scale. So we have to add all these up to find the total height of my building. So we have 22.6, and then we're going to add 6, then we're going to add 5.2. It's going to end up giving me 33.8 feet is the height of the building. Okay, so we have to add each of these three heights together to get my total height. All right? So now we're looking at bearings. And by the end of this, you will be one smart bear that is smarter than the average bear that will be the one to rule them all. Get it? Bear as in Yogi the Bear, smarter than the average bear. Ring as in Lord of the Rings. Bear rings. Lord of the Rings, the ring, the one to rule them all. All right, so a bearing is an angle measured clockwise from the north direction. So the boat is on a bearing of 42 degrees. Pretend the boat's going that way, not this way. Okay, so we have a boat here that's on a bearing of 42 degrees. It's going that way. Because here's my north, okay? Here would be east, here would be south, here would be west. And it's at 40 degrees. We go from there to there is 40 degrees. So let's try this out with an actual example. A ship travels 6 kilometers from Port P on a bearing of 120 degrees to position Q as shown. So here's my port P, and we're going to position Q. All right, and this is 120. Okay, because here's going to be north. Now, the ship changes direction at Q and travels north until it reaches point R. Okay, so here's going to be R. which is due east of point P. So it's directly east of point P. Okay? How far east of P is the ship at point R to the nearest 0.1 kilometers? Well, look at this. He traveled 6 kilometers here. Okay? This is going to be 90 degrees because it's straight north and straight east. So that there must be 90. Now, if this is 120, this has to be 90 because north and east. And so this here is going to be 30 degrees because we have 120 minus 90 will give me 30 degrees. And that's that little leftover there, which is 30 degrees. Now, looking at this, I have 30 degrees and I know my hypotenuse. And I want to find here my adjacent. I'm going to put this as x. Okay, so we want to find that x, which is my adjacent. Or in this case, we want to find PR. Okay, so PR is adjacent. So if we know hypotenuse and adjacent, we're going to have to use cosine. So we go cos 30, because it's ca, is equal to adjacent, which is going to be PR all over 6. Okay? We rearrange this, I'm going to get 6 cos 30 is equal to PR. Now I plug that into my calculator. Right here, just type in 6, and we have cos 30, and I'm going to end up getting 5.2. Okay, so I know this part here is now 5.2. Now part B says the ship continues traveling north for a further 12 kilometers. So it goes for a further 12 kilometers. Okay? Determine the bearing of the position from S to P. So we want to know now where is S to P. So this is S, and I want to know the bearing from S to P. So this is my bearing here. We don't go from here. That would be angled elevation, kind of, but we want this bearing here. So we're going to look at this here. I know this bearing is going to be equivalent to this here. So if this is x, then this is x. These two here are going to be equivalent. So I'm going to have tan. I know x is going to be equal to, now here we want opposite, 5.2, all over adjacent, which is 12. Okay? So let's continue that. We're going to have x is equal to tan, 1, we have 5.2 all over 12. So let's put that into my calculator. There we go. We're going to go second tan, 5.2, and then we're going to divide that by 12. And I end up getting 23 degrees. Okay? Another way we could have done it is we could have just found this angle here. Alright? We could have found this angle here, and by using tan, this is 12 over 5.2. Okay? Because we have my opposite and adjacent. So that's why we know it's tan. We could have found this angle and then gone 90 minus whatever that angle is, and that would have given you this to be 23 as well. That's the second way of doing it. So now it wants to know, if the ship maintains an average speed of 9 kilometers per hour throughout the journey, determine to the nearest tenth of an hour the time taken for the journey. Well, to start this off, let's see if I know all my distance. We go 6 kilometers here, then here we don't know. We do not know QR. That's unknown. But then we know RS is 12. So first I find my distance of QR. Is equal to, well, let's see, what do we know here? This is 30, this is 6, and we know QR. We want to know QR. So that's going to have to be opposite in that sine law. So we're going to go sine 30 is equal to opposite, which is QR, over my hypotenuse. Go down here, sorry, which is equal to QR, over my hypotenuse, which is 6. Alright? Now I'm going to continue this. And I'm going to get 6 sine 30, 6 sine 30, enter, and we end up getting 3. So QR is equal to 3. 3 kilometers. So now I know we have 6, if you look here, 6 plus 3 plus 12. So we went 6 plus 3 plus 12 kilometers. Okay? Which gives me a total of 1821. Now he was traveling at this speed, so kilometers per hour. We want to know to nearest tenth of an hour it took. So we're going to go speed is equal to distance over time. We want to know time, so time is equal to distance over speed. So I'm going to end up going here. We want time is equal to 21 over my speed is 9 kilometers. Which is going to end up giving me, plug this into my calculator, check it out, 21 divided by 9, it's going to be 2.3. And that's going to be hours. Okay? So, or in other words, we say 2 hours and 20 minutes. And that is your answer. Well, good luck as I see you tomorrow. Hopefully you understood all of that. Make sure if you have any questions to ask. See you tomorrow.